Welcome to the Deep Dive. We're here to cut through the noise and deliver insights you can actually use. Okay, picture this. Maybe it's Black Friday, millions are hammering your site, clicking buy now, and then boom, some small, maybe overlooked service, I don't know, the recommendation engine starts to choke. Without the right safeguards, that tiny glitch, it could ripple outwards, take down the whole checkout, poof, sales gone. Today we're looking at the invisible guardian built to stop that exact scenario, Hystrix. Our mission is to really unpack how this open-source library keeps complex systems, well, stable, even when bits fail. We're digging into sources like Hystrix, fault tolerance, and microservices.
In that scenario, it's not just theory, is it? It's a real-world headache. In today's software world, everything's connected. One service depends on maybe dozens of others. It's inherently fragile. A single failure can spread like wildfire. Widespread outages. Not good. Hystrix was specifically engineered to contain those fires. So yeah, our goal today isn't just the what, but the why. Why has Hystrix been so critical for reliability?
Right. So to get Hystrix, we need to rewind a bit. Back to 2012, that's when Netflix, the absolute pioneers in these massive distributed systems, they open source Hystrix. Their problem was pretty clear. How do you keep a giant streaming service up when, inevitably, things break? Hystrix was their solution. It provides fault tolerance, stops those cascading failures we mentioned, isolates services, manages latency, especially key for microservices. It's built on Java, and this is really interesting for a lot of developers. It integrates super smoothly with Spring Boot, Spring Cloud, the whole ecosystem.
And the how is fascinating. It's not magic, it's clever engineering. It uses a core idea called the circuit breaker pattern. Think of it like, well, the circuit breaker in your house, basically. Hystrix wraps every call your app makes to another service. It watches those calls constantly. If too many fail, maybe timeouts, exceptions, whatever, above a certain threshold, Hystrix doesn't just keep banging its head against the wall. Instead, it trips the circuit, opens it. Once that circuit is open, it immediately stops sending requests to that struggling service. And here's the really smart part. It redirects those requests to a fallback you've defined beforehand. So that immediately lessens the impact, stops the failing service from dragging everything else down, enhances stability hugely. It's like an automatic bypass valve.
Emergency bypass, yeah.
Exactly. Now, it's worth mentioning, Netflix itself has moved on for some newer things, maybe using tools like Resilience 4J now. But Hystrix, it's still incredibly robust, still widely used, especially in existing Spring Cloud setups. Its track record is solid.
Okay, that makes a lot of sense. So in this complex world of microservices where, like you said, failure is going to happen, what are the core problems Hystrix tackles that make it so vital? What change does it bring for developers and the business itself?
Well, it really enables a shift, doesn't it? From systems that shatter easily to ones that can bend. First up, fault tolerance. By isolating services, you stop one bad apple spoiling the bunch. No snowball effect. It's like fire doors in a building. A fire in one area doesn't mean the whole place goes up.
Right, containment.
Containment. Then the circuit breaker pattern itself. The system protects itself proactively. It stops hitting a service that's clearly down, gives it breathing room to maybe recover, a smart pressure release. For latency management, Hystrix sets timeouts. Your app doesn't wait forever for a slow service. Keeps things snappy for the user.
Which is huge for user experience, obviously.
Absolutely critical. Then there's real-time monitoring. You get dashboards, metrics, like system vital signs, spot trouble early. And for developers, that Spring integration is key. Turns complex fault tolerance logic into just, an Hystrix command annotation sometimes. Simple.
Wow, yeah.
And finally, thread isolation. Think of it as bulkheads on a ship. If one service goes rogue and uses up all its threads, it doesn't sink the whole application by hogging all resources.
So it's not just about stopping failure, it's about letting the rest of the system function as best it can. Graceful degradation. That must fundamentally change how teams think about deploying code, maybe even innovating, knowing that safety net is there.
Oh, absolutely. You hit the nail on the head. It often gave teams more confidence. They could push updates faster, try new things, iterate more freely, because the fear that one buggy dependency could crash everything was, well, lessened. It wasn't just about stability. It indirectly fueled innovation by reducing that fear factor.
Okay, so that's the why. Let's get into the nitty-gritty now, the how. How does Hystrix actually pull this off inside a microservice architecture? Which, as we know, is constantly dealing with network hiccups, latency spikes, services just plain going down. What are the mechanisms?
Right. This is where the clever bits are. Fundamentally, Hystrix wraps those calls to external services. It keeps an eye on them. If a certain number fail within a set time, say more than half the requests fail over 10 seconds, something like that, the circuit breaker changes state. It has
Yeah.
three main states. First, closed. This is the normal state. Everything's flowing, requests go through. Hystrix is just monitoring failures in the background. Healthy.
Okay, default state.
Exactly.
Yeah.
Then, if failures hit that threshold, it flips to open. When it's open, Hystrix completely blocks requests to that failing service, stops them dead. Instead, it immediately runs that fallback logic we talked about. It's like a bouncer saying, nope, you're cut off for now.
Protects the service from getting hammered further.
Precisely. And protects your application from waiting on it. Then, after a cooldown period, a configurable sleep window, it enters the half-open state. Here, it carefully lets just a few test requests through to the troubled service, like dipping a toe back in the water. If those succeed, great. Hystrix figures the service is back online and closes the circuit, back to normal. If they fail, bam, back to the open state immediately. This stops you from flooding a service that's still recovering, gives it a real chance to stabilize.
That's really smart, the self-healing aspect.
It is, and crucial alongside that are the fallback mechanisms. When a service call fails, or the circuit's open, Hystrix doesn't just throw its hands up and give you an error. It executes a fallback you've written. This could be anything, really. Maybe return some cached data, slightly old recommendations are better than none, right? Or a simple default response, sorry, can't fetch that right now. Or maybe even try calling a different secondary service if one exists. The point is partial functionality, a better user experience than just hitting a wall.
Okay, so circuit breaking stops the bleeding, fallbacks provide first aid. What about resource exhaustion? You mentioned thread pools.
Right, that's thread pool isolation, often called the bulkhead pattern. Hystrix gives each downstream service dependency its own dedicated pool of threads. Think of those watertight compartments on a ship again. A hole in one doesn't flood the others. So if calling, say, the user profile service starts hanging and ties up all threads in its pool, it won't starve the threads needed for the product catalog service or the shopping cart service. It contains the damage. Now, this does add a bit of overhead managing all those pools.
Sure, resources aren't free.
Definitely a trade-off, but often a worthwhile one for the stability it brings. Then there's straightforward timeout management. Hystrix lets you configure timeouts for every call. Seems basic, but it's vital. Stops your application getting stuck indefinitely waiting for a slow service. That kills responsiveness and eats resources. And finally, metrics and monitoring. Hystrix spits out a ton of real-time data, successes, failures, latencies, thread pool usage. You can view this on the Hystrix dashboard or feed it into tools like Prometheus. This observability is gold for finding and fixing issues fast, sometimes before users even notice. Gives you that clear window into system health.
Okay, so it's this whole package deal, circuit breaking, fallbacks, isolation, timeouts, monitoring. It's not just one thing, it's a system for resilience. It sounds incredibly powerful, but I guess, are there downsides? Complexities in getting it right, situations where maybe it isn't the best tool.
That's fair. No tool is perfect for everything, right? The importance of Hystrix, especially in preventing those cascading failures and just improving overall resilience with graceful degradation, that's undeniable. It helps with scalability, too, by managing resources better.
Right.
And developer productivity, especially with Spring Cloud, huge boost there. And that observability piece makes maintaining system health much more proactive. Basically, it delivers reliability even when the network is being, well, flaky, like it often is in distributed systems. For a long time, it really was the standard.
Okay, but you mentioned Netflix has moved on for some things. I've heard Hystrix is in maintenance mode. Is that right? Should people still be starting new projects with it today? What are the alternatives?
That's the key question now, isn't it? Yes, Netflix did place Hystrix into maintenance mode. That means it's stable, it works, it's fine for existing systems that rely on it. Many do. But for new development, they generally point towards Resilience 4J. Why the shift? Well, the landscape changed. One potential drawback of Hystrix is that thread pool overhead we mentioned. For systems with a huge number of dependencies, managing all those separate thread pools can have a performance cost, especially in very dynamic cloud-native setups.
Resource intensity.
Can be. And like any powerful tool, there's a learning curve. Understanding how to configure the circuit breakers, the fallbacks, the timeouts, thread pool sizes effectively, especially within Spring, it takes some effort.
So if I'm starting fresh today, building a new microservice app, what are these modern alternatives I might look at? How do they stack up against Hystrix?
Good question. The main one people compare it to is Resilience 4J. It's generally seen as more lightweight, less overhead than Hystrix's thread pool model. It offers similar patterns, circuit breakers, retries, rate limiters, and it's built with functional programming concepts in mind. More modern Java style, perhaps. The big but, though, is that it doesn't quite have the same deep, batteries-included Spring Cloud integration that Hystrix has enjoyed for years. That can be a big deal for Spring shops.
Right, the ecosystem matters.
Hugely. Then you have a different approach entirely with things like Envoy. Envoy is a service proxy. It often runs alongside your application, maybe as part of a service mesh like Istio. It handles things like circuit breaking and retries at the network level outside your application code. The advantage is it's language agnostic, works for Java, Python, Go, anything. The disadvantage, it's less tightly integrated with your application-specific logic compared to a library like Hystrix running inside your Java code.
Different layer of abstraction.
Exactly. So while there are great alternatives and the space keeps evolving, Hystrix's real enduring strength is that deep, battle-tested integration with Spring and its long history in production. For many Java microservices, especially those already in the Spring world, it's still a very solid, very reliable choice.
Okay, so let's wrap this up for our listener. What's the core message from our deep dive today?
I think the key takeaway is that Hystrix really was, and honestly in many systems still is, a foundational piece for building resilient microservices, particularly in the Java and Spring Cloud world. It took on the messy complexity of service-to-service calls and gave developers tools to build systems that could actually handle failure gracefully. It basically allowed innovation to happen faster because that safety net was there. Absolutely. And that maybe leads to a final thought for you to chew on. In this world we live in now, digitally speaking, everything relies on everything else. Your favorite app probably talks to tens, maybe hundreds of back-end services. How have tools like Hystrix fundamentally shifted what we expect from technology? We almost demand constant availability now, even when we know failures are happening under the hood. So what does that imply for the next generation of resilient systems? How do we build for a future where perfect uptime is impossible, but always available services, increasingly the user expectation?
That's a deep one. Building for imperfection, expecting perfection. A real challenge. Thank you for joining us on this deep dive. We hope you found it useful and definitely encourage you to keep exploring this fascinating area of system resilience.